Welcome to the session on differentiation, differentiating complex trig functions. The objectives for this session are to differentiate trigonometric functions using rules such as the chain rule, product rule, and quotient rule. The quotient rule states that if y equals u over v, then dy dx equals v du dx minus u dv dx all over v squared, where u and v are functions of x. The product rule states that if y equals u times v, then dy dx equals u dv dx plus v du dx, where u and v are functions of x. Let's now take a look at an example. Pause the video and have a go. Press play when you're ready to view the solution. In this example, given that y equals tan x, we are required to find dy dx. So let's solve this. Now we have that y equals tan x. This can be expressed as sin x over cos x. So we let u equal sin x and v equal cos x so that we can apply the quotient rule. Since u equals sin x, du dx equals cos x. And since v equals cos x, we have that dv dx equals minus sin x. We can now use the quotient rule and plug in the terms. So dy dx equals v, which is cos x, times du dx, which is cos x, minus u, which is sin x, times dv dx, which is minus sin x, all over v squared, which is cos x squared. And so we have that dy dx equals cos squared x plus sin squared x all over cos squared x. And of course the numerator is equal to 1 and the denominator stays as it is, giving us that dy dx equals sec squared x. Our result from the previous example, namely that if y equals tan x, then dy dx equals sec squared x, can be generalized to the following. If y equals tan kx, then dy dx equals k times sec squared kx. Let's now take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's take a look at part A first. We are required to differentiate y equals tan 3x. So let's solve this. Now y equals tan 3x. So if we let u equal 3x, then y equals tan u. We also have that du dx equals 3 and dy du equals sec squared u. So if we apply the chain rule, in other words dy dx equals du dx times dy du, we obtain that dy dx equals 3, which is the value of du dx, times sec squared u, which is the value or expression for dy du. Since the value of u was introduced by us, we need to reinsert the expression in terms of x. So we have that dy dx equals 3 sec squared 3x. Now let's take a look at part B. We are required to differentiate y equals x squared tan 3x. So let's solve this. Since we're dealing with the product, we're going to apply the product rule. So we let u equal x squared and v equal tan 3x. Therefore, we have that du dx equals 2x, and from part A we have that dv dx equals 3 sec squared 3x. Using the product rule gives us that dy dx is equal to u, which is x squared, times dv dx, which is 3 sec squared 3x, plus v, which is tan 3x, times du dx, which is 2x. And so if we tidy up this expression, we obtain that dy dx is equal to 3x squared sec squared 3x plus 2x tan 3x. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solution. We are required to differentiate y equals tan x to the power 5. So let's solve this. Y equals tan x to the power 5 can be rewritten as tan x all raised to the power 5. This is simply a matter of notation. So if we let u equal tan x, then we have that y equals u to the power 5. We also have that du dx equals sec squared x, and dy du equals 5u to the power 4. So applying the chain rule, dy dx equals du dx times dy du, we obtain that dy dx equals sec squared x times 5u to the power 4, which is equal to 5 sec squared x times tan x to the power 4. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solution. We're required to show that if y equals sec x, then dy dx equals sec x tan x. So let's solve this. Y equals sec x can be re-expressed as 1 over cosec. So we can apply the quotient rule and let u equal 1 and v equal cosec to give us du dx equals 0 and dv dx equals minus sin x. Then applying the quotient rule, as shown here, gives us that dy dx is equal to cosec, which is v, times 0, which is du dx, minus 1, which is u, times minus sin x, which is dv dx, all over cosec squared, which is v squared. Tidying this up gives us that dy dx is equal to sin x over cos squared x. However, we want to keep an eye on what we're being required to prove. Notice that we're required to show that dy dx equals sec x times tan x. So let's see if we can re-express this in another way. we have 1 over cosx times sin x over cosx, which can be re-expressed as secx times tanx, and this is what we are required to prove. So we have that if y equals secx, then dy dx equals secx tanx. Using similar techniques, we can differentiate cosecx and cotx to give us these results. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solution. We are required to differentiate y equals sec 3x over x squared. So let's solve this. Since this is a quotient, we're going to let u equal sec 3x and v equal x squared. Notice that we also know that the derivative of sec kx is k sec kx tan kx. And so we can differentiate. When we differentiate u, we obtain du dx equals 3 sec 3x tan 3x. And of course, when we differentiate v equals x squared, we obtain dv dx equals 2x. And so applying the quotient rule gives us that dy dx is equal to x squared times 3 sec 3x tan 3x minus sec 3x times 2x all over x to the power 4. And then if we tidy up, we obtain that dy dx is equal to 3 sec 3x tan 3x over x squared minus 2 sec 3x over x cubed. And if we factorize, taking out sec 3x as a common factor, and taking out 1 over x cubed as a common factor, as shown here and here, we then have this expression in the brackets, 3x tan 3x minus 2. And so we have our expression for dy dx. Now let's have a go at another example. Pause the video and have a go. Press play when you're ready to view the solution. We are required to differentiate y equals cosec x cubed. So let's solve this. We can re-express y equals cosec x cubed by letting u equal cosec x, and then that gives us y equals u cubed. We also know that the derivative of cosec kx is minus k cosec kx cot kx. And so we have that du dx equals minus cosec x cot x and dy du equals 3u squared. Let's now apply the chain rule to give us dy dx equals minus cosecx cotx times 3u squared. We need to express this in terms of x, as shown here. And so if we tidy up, we obtain minus 3 times cotx times cosec x cubed. And now for the next example. Pause the video and have a go. Press play when you're ready to view the solution. We are required to show that the derivative of y equals arccos x is minus 1 over root 1 minus x squared. So let's solve this. Since y equals arccos x, we can rewrite this as x equals cos y. And therefore we have that dx dy equals minus sine y. Using the fact that dy dx equals 1 over dx dy, we can rewrite dy dx as minus 1 over sine y. But since sine y squared plus cos y squared is identical to 1, sine y is equal to root 1 minus cos squared y, which is equal to root 1 minus x squared. And therefore dy dx equals minus 1 over root 1 minus x squared. If we use similar techniques to those shown in the previous example, we can prove the following. As shown on your screen. Now let's take a look at a final example. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. Given that y equals arccos x squared, we are required to find dy dx. If we let t equal x squared, we have that dt dx equals 2x. We also have that y equals arccos t. Recall that the differential of arccos x is minus 1 over root 1 minus x squared. And therefore dy dt equals minus 1 over root 1 minus t squared. If we recall the chain rule, dy dx equals dt dx times dy dt, we have that dy dx equals 2x times this expression for dy dt. This can be rewritten as minus 2x over root 1 minus x to the power 4. This brings us to the end of this session. If you have understood its contents, you should be able to differentiate trigonometric functions using rules such as the chain rule, product rule, and quotient rule. Thank you very much for listening. To understand this topic in greater depth, Do attempt the exercises in your textbook related to this topic.